So, vectors and vector subspaces. Linear combinations allow us to build vector spaces and vector subspaces. And our goal is to use the geometrical point of view of linear combinations to see how does this happen. Consider, for example, these two vectors, 1, 2, and 3, 0. So 1, 2, you find here in pink, and 3, 0, the yellow one. Now just imagine that we write every possible linear combination of these two vectors. In other words, we have A, 1, 2, plus B, 3, 0, where A and B are just real numbers of your choice. But now you just start choosing A and B as any number that you like. You're just choosing over and over again. As you do that, you draw a picture of it. Just use the parallelogram rule that you saw previously, and you start doing that over and over again. Eventually, we will cover the entire r² plane. So the plane that you see here will cover every point in this plane by some vector that starts at origin and ends up here. Can you see? Another way to put it is that every single point that I'm drawing can be constructed by some appropriate linear combination of 1, 2, and 3, 0. So you have to choose A and B appropriately. So this is the idea. The idea that you can construct this set of vectors starting just from 2. And we have a special name for it. It's called the span. The span of the list of vectors 1, 2, and 3, 0. This span is what we call r². Notice something very important. Any linear combination of these two vectors yield another vector in r². This is very important to notice. So there is no escape from r², no matter the A and B that you choose. Another way to describe this space, this r² space, is by specifying the form of the elements that live in this set. What do I mean by the form? Well, look at this generic linear combination. Let me write it in another way. This is the same thing as A plus 3B, 2A, and 2A. So it's a column vector whose entries are A plus 3B, and the second entry is 2A. So this is a generic form of the elements in this set. In fact, I can write it like this. So r² is a set of all elements A plus 3B and 2A, such that A and B are real numbers, and r² is this set as well. So rather than specifying 1, 2, and 3, 0 as the building blocks to construct everything else, I just can give you the form of the elements that live in there. This basic example essentially shows us what is a vector space. It is a set of things which is closed under linear combinations. So any linear combination of its elements yield another element in the set. Notice something else. Imagine that you have now, instead of these two vectors, you have the vectors 1, 0 and 0, 1. Geometrically, this means this vector and this vector. Notice that the span of this list is r² as well. So this is very important because you can see that the vector space r² can be generated in many distinct ways. As long as you introduce here in this list two vectors that point in distinct directions, the span of it is always r², which is no surprise. After all, R squared is closed under linear combinations. So you can choose any starting point for it.